Hi, it is JIT UA Courses, and welcome to the 7th lesson of the .NET Developer series in which we will cover the most relevant topics to become a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will continue with the internal elements. In the last lesson, we studied the methods of classes. It is worth emphasizing once again that the objects of the class have certain characteristics, data, that the classes carry with them. Such data is stored in fields or properties of the class. However, objects of the class also have certain behavior that characterizes them, and this behavior is represented by methods. However, the behavior of classes is rarely very linear. Often we need to change the course of our program depending on the conditions in which it works. Or we need to repeat a certain operation many times. For this, in the C# language, we use conditional operations and loops in class methods. Conditional operations. Conditional constructions, one of the basic components of many programming languages. They direct the work of the program along one of the paths depending on certain conditions. One such construct in the C# programming language is the if/else block. The if/else block checks the truth of a certain condition and, depending on the results of the check, executes certain code. Its simplest form consists of an if block like this. The if keyword is followed by a condition. The condition must represent a bool value. It can be a bool value directly or the result of a conditional expression or another expression that returns a bool value. And if this condition is true, equal to true, then the code that is placed further after the condition inside the curly brackets is triggered. Look at this example. The if block will be executed if condition number 1 is bigger than number 2 is true and number 1 equals 8 is true. The else expression. But what if we want some action to be taken if the condition is not met as well? In this case, we can add an else block. Like this, the following example. Else if. But in the example above, when comparing numbers, we can count 3 states. The first number is greater than the second, the first number is less than the second, and the numbers are equal. Using the else if construct, we can handle additional conditions. Like this, the following example. If necessary, you can add several else if expressions. Like in this example with names. Ternary operation. The ternary operation also allows you to check a condition and perform some action depending on its truth. It has the following syntax. There are 3 operands here. Depending on the condition, the ternary operation returns the second or third operand. If the condition is true, then the second operand is returned. If the condition is false, then the third. Here, the first operand, condition, is the expression x is greater than y. If it is true, then the second operand is returned, the result of the addition operation. If the condition is false, then the third operand is returned. The result of the ternary operation, the second or third operand depending on the condition, is assigned to the variable z. Loops. Loops are control constructs that allow you to perform an action multiple times depending on certain conditions. C# has the following types of loops. For each. While. Do while. For loop. The for loop has the following formal definition. The declaration of the for loop consists of 3 parts. The first part of the loop declaration is some action that is performed once before the loop is executed. Usually, variables that will be used in the loop are defined here. The second part is the condition under which the loop will be executed. As long as the condition is true, the loop will execute. And the third, some actions that are performed after the completion of the loop block. These actions are performed every time a loop block is completed. After the declaration of the cycle, the actions of the cycle are placed in curly brackets. Consider the standard for loop. Here, the first part of the loop declaration creates and initializes the variable I. The second part is the condition I is less than 3. That is, while the variable I is less than 3, the loop will be executed. The third part, the actions performed after the completion of the actions from the loop block, increases the variable I by 1. The entire process of the cycle can be represented as follows. The variable I is defined. The condition I is less than 3 is tested. It is true, because 1 is less than 3, so the loop block is executed, namely the console.writeLine statement, which outputs the value of variable I to the console. The loop block has finished execution, so the third part of the loop declaration, 1++ is executed. After that, the variable I will be equal to 2. The condition I is less than 3 is checked again. It is true, because 2 is less than 3, so the loop block is executed again, console.writeLine. The loop block has finished executing, so the expression I++ is executed again. After that, the variable I will be equal to 3. The condition I is less than 3 is checked again. It now negates false because the value of variable I is not less than 3, so the loop terminates. Next, the rest of the program, which follows the loop, will be executed. As a result, the loop block will execute 2 times until the value of I becomes equal to 3. And each time this value will be increased by 1. A single execution of a loop block is called an iteration. Loop do while. In the do loop, the loop code is first executed, then the condition in the while statement is checked. And as long as this condition is true, the cycle repeats. Here the loop code will execute 6 times until I becomes 0. But it is important to note that the do loop guarantees at least one execution of actions, even if the condition in the while statement is not true. That is, we can write code like this. Although our variable I is less than 0, the loop will still execute once. The while loop. Unlike the do while loop, the while loop immediately checks the truth of some condition, and if the condition is true, the loop code is executed. The for each loop. The for each loop is designed to iterate over a collection of elements. It has a definition like this. After the for each statement in parentheses, the variable is first defined. Then the keyword in and then the collection whose elements need to be iterated over. When executed, the loop sequentially iterates over the elements of the collection and places them in a variable, and in the loop block we can perform some operations on them. For example, a string is essentially a collection of characters, and .NET allows you to iterate through all the elements of a string, its characters using a for each loop. Here the for each loop runs through all the characters of the string Tom, and each character places the character variable C. In the loop block, the value of the variable C is output to the console. Since there are 3 characters in the string Tom, the loop will execute 3 times. It is worth noting that the type specified in the loop declaration must correspond to the type of elements of the collection being iterated. Yes, string elements are values of type char, characters. Therefore, the variable has type char. Next, we'll take a closer look at collections in .NET and which collections can be iterated over using a for each loop. Continue and break statements. Sometimes there is a situation when you need to exit the cycle without waiting for its completion. And here we can use the break operator. Although the loop condition says that the loop will run until counter I reaches 9, the loop will actually run 5 times. When counter I reaches the value 5, the break operator will be triggered and the cycle will end. Now let's set ourselves another task. And if we want the loop not to end during the check, but simply to pass the current iteration. For this, we can use the continue operator. In this case, the loop, when it reaches the number 5, which satisfies the test condition, will simply skip this number and go to the next iteration. It is worth noting that the break and continue statements can be used in any type of loops, nested loops. Some cycles can be nested within others. Like in this example. In this case, the for loop is executed 9 times, that is, it has 9 iterations. But within each iteration, a nested loop is executed 9 times. This is all for this lesson. Thanks for watching. Hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell not to miss the following videos in the series. Feel free to leave a comment and like this video. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.